Stars. The sight of the starry sky is mesmerizing. It seems that one can admire it endlessly. There are so many mysteries and riddles. But what are stars? What are space objects called? What are stars? Stars are large celestial bodies scattered in space. Some substances remain in them due to mutual attraction. Stars have high temperatures, so they emit light that can be seen by observers on Earth. Objects are heated so strongly that any substance, even metal, is in a gaseous state, and their combination is called plasma. Why stars glow? Everything depends on the temperature difference between the core and the surface. Inside a star, it can reach 10 million degrees or more. Because of this, thermonuclear reactions are constantly occurring in the cosmic object, turning some chemical elements into others. For example, hydrogen, which makes up most stars, turns into helium in their cores. Due to this, there is a brightness that can be seen by the inhabitants of the Earth. Interesting fact, a person can see the stars of 3 nearby galaxies in the sky: Andromeda, Triangle, and the Milky Way. Powerful telescopes are needed to observe distant space objects. Naming stars. People began to give names to individual cosmic bodies and constellations in ancient times. At that time, people imagined the sky as the abode of various mythical creatures, after which they were named. Most of them are still in use today. The names of the constellations of the northern and southern hemisphere are surprisingly different. Here rule not mythical creatures, but different parts of ships and sea creatures. The fact is that the scientists of the southern hemisphere were poorly known in the ancient world. Its active development began in the era of great geographical discoveries. It makes sense that many constellations of the southern hemisphere were first discovered by sailors, who named them according to their preferences, so appeared in the sky keel, stern, etc. Now scientists recognize 88 constellations. 12 of them belong to the zodiac. The brightest celestial body they have is designated by the Greek letter alpha, the next, beta, etc. Individual letters are designated by an alphanumeric abbreviation. In addition, celestial bodies are classified by color and size. For example, blue giants or brown dwarfs. Star formation. The birth of a star is the fusion of hydrogen and helium molecules into one cloud. It begins to rotate. Internal gravity appears. This fact accelerates the rotation. The outer space of the cloud gradually begins to resemble a disk and the inner space begins to resemble a spherical cluster. The temperature of the material increases, as does its density. This leads to the formation of a globular protostar. Over time, the pressure and heat increase to 1 million Oc. This leads to the fusion of atomic nuclei. At this point, a new star begins to shine. The celestial body is almost invisible to the observer's eye because it is surrounded by a powerful cloud of gas and dust. As a result of nuclear fusion, a certain amount of atomic mass is gradually converted into energy. All this time, the star is moving under the influence of various forces. They mostly revolve around galaxies or space objects with a strong gravitational field. Interesting fact, stars can be seen in space at any time of day because time there is not divided into day and night. Stellar evolution. All cosmic bodies have a certain cycle of development called evolution. The mass of stars has a great influence on this process. The heavier the object, the shorter its life cycle. Cosmic bodies with an intermediate mass, i.e., 5 to 8 times heavier than the Sun, emerge from a cloud that can be up to 100,000 light-years in size. When the temperature inside reaches 3,725 C, the nebula forms a protostar. When hydrogen fusion begins, it becomes an object of varying brightness. Due to compression under the influence of gravity, the expansion process is balanced. The star begins to gain energy from the synthesis of hydrogen in its core. The formation of the object takes about 10 million years. When all the hydrogen is converted into helium, the matter under gravity becomes the core, which heats up rapidly. The outer layers expand, which quickly cool down under the influence of the external environment. This is how the red giant is formed. Next, chemical processes with helium begin. When it is completely transformed into other matter, the nucleus expands its shell as the temperature rises. This leads to the formation of a white dwarf, which can reach temperatures of 100,000 C. The products needed for heating will eventually run out, so the object will gradually cool down. After a few billion years, it will become a black dwarf and cease to exist. Evolution happens fastest in high-mass stars. It takes between 10,000 and 100,000 years from the creation of an object to the end of its life cycle. At the beginning of life, they are characterized by high temperature, bright and large. The star has a deep blue color. Gradually, it becomes a red supergiant, in which carbon is actively transformed into heavy elements. An iron core is formed. It can be up to 6,000 kilometers wide. Its nuclear radiation cannot resist gravity. When the mass of the cosmic object is about 1.5 times the mass of the Sun, the core collapses. This leads to the formation of a supernova. As it collapses, its temperature rises to 10 billion Oc, causing iron to decay in nerve cells. In a second, the core shrinks to 10 kilometers in size. Then the explosion occurs. Then there are two ways things could happen. If the remaining core weighed less than 3 suns, it would become a neutron star. The object spins and emits radio pulses. If the nucleus were heavier than 3 solar masses, it would collapse completely and a black hole would form in its place. Low-mass stars are the slowest to form. The reality is that they will slowly use up their fuel reserves. Their lifespans range from 100 billion to trillion years, so such objects are not dead yet. After all, the age of the universe has been determined to be 13.7 billion years. Red dwarfs cannot fuse with anything but hydrogen. As a result, they can't grow. Such luminaries slowly cool down and eventually become black dwarfs, after which they end their lives. Interesting fact, the first map of the starry sky was made about 3,000 years ago. Characteristics of stars. People use certain characteristics to describe stars perfectly. Brilliance. This concept was introduced by Hipparchus in 125 BC. He counted groups of stars according to their apparent brightness. The first ones are the most visible, the sixth ones are the faintest. At that time, however, it was not yet known that the distances between the Earth and other cosmic objects distort the light coming from them. Therefore, they now include a term such as true brightness when describing stars. Color depends on the temperature of the object. There are stars of blue, red, yellow, and white colors. Each spatial object has only one color. However, due to the chemical processes occurring inside, flashes of different light spectrum appear on the surface. By studying these phenomena, scientists find out what elements a star contains. Surface temperature. This is measured in Kelvin, where 0 equals minus 273.15 C. Temperature is affected by brightness, color, and mass. Magnitude. The diameter of the Sun is usually assumed to be constant. Alpha Centauri has a stellar magnitude of 1.5. Larger objects are also included. Red supergiants are 1,000 times larger than the Sun. Magnitude affects the brightness of the star. Mass. The Sun is also standard here. Alpha Centauri is 1.8 versus. Weight affects the temperature. Magnetic field. Each star is surrounded by a strong magnetic field. It is able to focus on certain areas of the target, causing flares and explosions. The faster a star rotates, the stronger the magnetic field around it. Metallicity. This indicator shows how many elements with a mass greater than helium the star contains. There are 3 generations of the metal. Scientists are still looking for the oldest 3, which has no heavy elements. Types. In addition to mass, size, etc., stars are divided into different types with unique properties. Main sequence stars. This indicator is based on the Hertzsprung-Russell diagram. In it, the stars are arranged diagonally. The brightest blue are in the upper left corner. The dim red one is in the lower right corner. Main sequence stars have the same nuclear reactions as their nuclei, namely the conversion of hydrogen to helium. The spectral class and temperature of a star depends on its mass measured relative to the Sun. Red giants and supergiants. The surface temperatures of these stars range from 3,000 to 500 K. However, they have a brighter glow. Helium is burned inside the object, which is then converted to carbon. Red and orange colored giants are located above the main stars in the Hertzsprung-Russell diagram. They are 100 to 800 times the diameter of the Sun, and in some cases YV Canis Majoris 1024 times the diameter of the Sun. White dwarfs. They represent the final stage of stellar evolution. These are essentially the nuclei of objects that have lost their outer shells due to expansion processes. They are small in size, 100 times smaller than the Sun, and low in luminosity, 10,000 times smaller, although they have almost the same mass as the Sun. The latter is due to the high density of the matter they contain. White dwarfs are clots of plasma with an electron core without energy sources. Their luminescence is due to the wear and tear of thermal reserves. Protostar. It is a cluster of gas formed after the collapse of a molecular cloud. It still cannot be called a full-fledged star. The development phase lasts about 100,000 years. Then gravity increases and the reservoir begins to collapse. The gas gradually builds up, releasing energy. This is where the rest of the star formation process begins. Brown dwarfs are cosmic objects that are too big for planets but too small for stars. Their mass reaches 0.8 solar energy. Their formation process is similar to that of ordinary stars, but they lack the pressure and temperature to begin nuclear fusion. They contain light elements, boron, beryllium and lithium, deep within them. When the reactions between them stop, the object closes up and becomes a cosmic body like a planet. The possibility of the existence of brown dwarfs was proven long ago, but for a long time scientists could not observe them directly from space. The first such object was discovered in 2004 in the constellation Hydra. This is 2 meters 1207. Variable stars are objects whose luminosity index has changed 1 or more times. This may be due to internal processes and various other reasons. In the past, people considered changes in the light of space objects as supernatural. From a scientific point of view, attention was paid to this issue back in the 17th century. Since the 19th century, they have been categorized by their mechanisms of brightness change. Excitable variable stars are 2 nearby objects that sometimes cover each other from the Earth's point of view. Therefore, their brightness varies. Pulsating variable stars change their brightness due to the regular contraction and expansion of the cosmic object. This is because their gravity and internal pressure are unstable. During pulsation, the size of the emitting region changes, resulting in a change in brightness. Irregular variable stars have more complex causes of light pulsation. Science still doesn't know much about them. T-Taurus stars, this is the name given to objects that are an intermediate stage in the development of a protostar, when all of its energy is generated by the effects of gravity. They are not yet hot enough to start nuclear fusion. T-Taurus stars, observers have observed gusts of wind, large spots, and bursts of X-rays. The duration of the processes is 100,000 years. Wolf-Rayet-type stars, such stars are about 10 times larger than the Sun. They are characterized by high temperatures up to 50 K and brightness. Among other stars with similar characteristics, this type of luminosity is characterized by a special unique spectrum. The formation of Wolf-Rayet stars is still a matter of controversy. The most popular version is that they come from the helium remnants of large stars. At the moment, scientists have found 230 stars of this type. Interesting fact, on a clear night, a person can see up to 3,000 stars with the naked eye. Supernovae are objects in which an explosion has occurred as a result of evolutionary processes. This kind of phenomenon can be seen from a distance. For an observer on Earth, it looks like a strong and spontaneous amplification of starlight, which can last up to 10 days. Similar phenomena can be seen even during the day with the naked eye. Supernovae are distinguished from new stars by their explosive power. Neutron, if the mass of the star was less than 1/35 of the Sun, it will not become a white dwarf after the explosion, but will become a supernova. The result of this process is a nucleus. It is called a neutron star. This is due to the compression of protons and electrons under the influence of gravity. If the mass of the object was more than 3 times the mass of the Sun, a black hole will form at the site of the explosion. The radius of a neutron star rarely exceeds 20 kilometers. The object has a strong magnetic field, which is created due to its rapid rotation, 1,000 revolutions per minute. Double stars, it is a system of 2 stars that are gravitationally attracted to each other. Some objects not only revolve around each other, but also exchange the masses of their matter. About 50% of all stars in our galaxy belong to this type. Binary symbols are denoted by Latin letters. A is brighter and more massive. B is dim and bright. The structure of stars in the universe. The stars are mostly in the main sequence stage and consist of a nucleus, corona, photosphere, and chromosphere. Thermonuclear reactions are constantly taking place in the subject's intestines. The resulting energy travels through the radiation zone. The force moves through convective regions due to burning gases. The photosphere of a star refers to its surface. This is the opaque part. Then comes the chromosphere, which has a reddish hue due to the presence of hydrogen. The corona is the outer sphere of the star. This part of the object has a high temperature and can be attached to the outer layers due to convection. Atmosphere radiation is produced in the star's atmosphere, which is visible to observers from Earth. It consists of 4 zones: the luminous and chromospheric zones, the rotating layer, and the corona. Many objects have a variable stellar wind. This is the name given to the process of the expulsion of substances contained in the atmosphere into space. The appearance of stellar wind indicates instability in the atmosphere. This phenomenon is strongest for high-mass objects. Classification. The first classification of stars was made by the Italian astronomer Angelo Secchi in 1863. He divided the luminaries into 4 spectral classes, to which, after further research, another one was added. There are now 8 of them. In addition, each category is divided into 10 types. It all depends on the surface temperature of the objects. According to the Morgan-Keenan system, mass and luminosity values are added to the above indicators. The largest star in the universe. Researchers at the Bonn Observatory discovered the largest star in the universe in 1860. However, it has only recently been fully studied. This is the star in the constellation Shields. Its radius is 1,700 times larger than the Sun. It is located at a distance of 9,500 light-years from Earth. If Scuddy was in the position of the Sun, it would have captured the first 5 planets and entered the orbit of Jupiter. Technological capabilities are improving every year. Perhaps in a few years people will find a new, larger star. The smallest star in the universe. The nearest star is the red dwarf Proxima Centauri. Its size is modest to 12.3 times the mass of the Sun and 200 kilometers across. It is about half the size of Jupiter, but the structure of these objects is different. A star heavier than a planet. Proxima Centauri is very faint. You can see it in the sky only with the help of special equipment. Interesting fact, the smallest star visible to the naked eye is 61 Swan. Its mass is 66% of the mass of the Sun. Which star was the first? Scientists believe that the universe originated from the Big Bang 13.7 billion years ago. At first, the temperature in space was very high, which did not allow the formation of stars and other objects. After a few million years, it shrank. Gravitational forces began to pull hydrogen and helium together. Then it was time to achieve the perfect temperature and pressure ratio. Hydrogen began to synthesize into helium. Because of this, stars accumulated to a large mass up to 150 solar masses. That's how the first generation was born. After a few million years, most of them exploded. But during their existence, they managed to form heavy elements, which flew into outer space after their death. This, in turn, led to the formation of stars as people observe them today. Observational history. The starry sky has fascinated people since ancient times. At first it was given mythical properties, then mankind learned to use it for practical purposes. For many centuries, sailors from different countries steered their ships by the stars. People have always been curious. They wanted to study the starry sky, to understand the laws by which the stars move. Therefore, astronomy is considered one of the oldest sciences. Technological progress has not stopped. Telescopes and other necessary instruments appeared. In the 17th century, the law of gravitation and motion was discovered. Over time, people realized that many stars are similar to the Sun and, therefore, obey the same laws of physics. Photography and spectroscopy. Analysis of light waves coming from an object appeared in the 19th century. It allowed people to penetrate into the composition of the stars and understand the basic principles of the movement of the luminaries. In 1937, the first radio telescope was created, which allowed the study of radiation from stars. This allowed astronomers to better study the internal structure of space objects. 1990, the first Hubble Space Telescope was launched. This allowed scientists to study areas inaccessible to observers from Earth. Solar system. The Sun has a tremendous gravitational force that allows it to hold the planets close to it, forming the entire system. They orbit each other and have certain characteristics depending on their location. Scientists are constantly exploring the solar system and are constantly making incredible discoveries that help us better understand the structure of the cosmos. What is a solar system? The solar system is a collection of planets orbiting around a central star. Scientists have been able to determine that it is approximately 4.57 billion years old and was formed by the gravitational compression of a cloud of gas and dust. At the heart of the system is a bright star, the Sun, which contains planets and other objects. Make them rotate a certain distance. Its diameter is several times larger than other gravitational field objects. Interesting fact, the mass of the Sun is so great that all the other planets in the system are only 0.14% of its mass. In addition to the star, the solar system has 8 large planets and 5 dwarf planets. It is located in the Milky Way galaxy below Orion. Formation. Since the solar system is billions of years old, people can only speculate how it formed. The most popular is the fog theory, which was introduced by scientists Laplace, Kant and Swedenborg in the 18th century. It is based on the fact that the system was formed by the gravitational collapse of one part of a huge cloud of gas and dust. The hypothesis has since been supplemented by space exploration data. The process of formation of the solar system is now described by the following steps. 1. In the beginning, in this region of the universe was a cloud of helium, hydrogen, and other substances formed by explosions. Old stars in a small part of it began to compact, which became the center of gravitational collapse. Gradually, it began to attract the surrounding subjects. 2. Because of the attraction of matter, the size of the cloud began to decrease and the speed of rotation increased. Its shape gradually changed to a lamellar shape. 3. As compression increased, the density of particles per unit volume increased, causing the matter to gradually heat up due to repeated collisions between molecules. 4. When the collapsing center of gravity heated up to several thousand Kelvin, it began to glow, indicating the formation of a protostar. At the same time, other condensates began to form in different regions of the disk, which in the future would serve as centers of gravity for the formation of planets. 5. The final stage of solar system formation began when the temperature of the center of the protostar exceeded a few million kelvins. Helium and hydrogen then underwent a fusion reaction that led to the birth of the perfect star. The remaining compacts of the disk little by little formed planets that began orbiting the Sun in the same direction, being in the same plane. This process took a very long time, and scientists can only guess how many years it took for the solar system to form. Structure of the solar system. At the center of the solar system is the Sun, which is composed of helium and hydrogen. Its surface temperature is about 6,000 degrees Celsius, and the sphere is many times the size of other objects in its gravitational field. The star is a yellow dwarf. Interesting fact, the Sun attracts objects to light years away. It is about 18.9 trillion kilometers across. At different distances around the star are the planets, which scientists divide into two groups: terrestrial planets and gas planets. Earth group planets. The Earth group is closer to the Sun. Its planets have a rocky texture and high density, making them smaller than the gas giants. Mercury, the closest planet to the Sun, is also the smallest planet in the system. It has a radius of only 440 kilometers. It gets its name in honor of Mercury, the god of commerce. Its surface is gray, which is why many people compare it to the Moon. The planet has no satellites and is almost completely devoid of atmosphere by strong solar winds. Venus, the second planet from the Sun, is named after the ancient Roman goddess of love. The peculiarity is the absence of natural satellites and a high concentration of carbon dioxide in the atmosphere. The radius of Venus is almost identical to that of Earth, 6,051 kilometers, which is only 5% less. This is why the planets are called brothers and sisters. However, Venus is very different in appearance, as it resembles a milk bowl. The surface consists almost entirely of petrified lava with rare meteorite craters. Earth, the third planet from the Sun, the only one whose territorial areas are filled with water. Due to favorable climatic conditions and sufficient resources, it is the only source of life in the solar system. The planet has a radius of 6,378 kilometers. Mars, red planet, is the farthest from the Sun and belongs to the Earth group. It is also considered the smallest after Mercury. Its radius is 3,396 kilometers. Earth consists mainly of sandy and clay landforms that are divided into light and dark areas called continents and seas. Mars is of great interest to scientists in the 21st century. Since the planet is relatively accessible, Mars rovers are regularly sent out to collect data. Gas group planets. This group consists of 4 gas giants that are farther from the Sun than the other planets. Its huge size is due to its low density composition and large amount of gaseous matter. Jupiter, the largest planet in the solar system. It has a radius of 69,912 kilometers, which is almost 20 times the radius of Earth. Scientists still cannot determine the exact composition of the planet. They only know that it contains more xenon, argon, and krypton than the Sun. Jupiter also has 67 satellites, some of which look like planets. For example, Ganymede is 8% larger than Mercury, and Io has its own atmosphere. There is also a theory that Jupiter was meant to become a full-fledged star, but remained a planet during its developmental stage. Saturn, the 6th planet known for its icy rings and rock meteoroids. Saturn has a radius of 57,360 kilometers. Scientists have not yet studied in detail the composition of the surface, but were able to show that it contains almost the same chemical elements as the Sun. There are 62 satellites around Saturn. Interesting fact, rings have recently been discovered in other gas giants besides Saturn, but they are not so remarkable. The reasons for their appearance can only be speculated at this point. Uranus, the third largest planet in the solar system. It has a radius of 25,267 kilometers. Uranus has a temperature of minus 230 degrees Celsius, making it the coldest planet. It also has a unique feature. The axis of rotation is located at an angle, because of which the planet gives the impression of a rotating sphere when moving. The surface consists mostly of ice with small amounts of helium and hydrogen. Neptune, the eighth planet from the Sun, was discovered not by observation, but by mathematical calculations. Observing the anomalies in the motion of Uranus, scientists have suggested that they are caused by the presence of another large celestial body. Neptune has a radius of 24,547 kilometers. The surface is similar to uranium, but is driven by the system's strongest winds, accelerating up to 260 meters per second. Order of orbits: each planet has its own particular orbit in which it revolves around the Sun. The time it takes for it to return to the same point after coming full circle is called a year, most often measured in Earth days. Mercury is closest to the Sun, which makes it orbit the Sun in the smallest orbit, and it has a year of 88 days. Venus makes a complete revolution around its star in 224 days. For Earth, a year lasts 365 days. Mars takes almost twice as long to complete a full revolution as the third planet, 687 days. Jupiter, which is the nearest gaseous giant to the Sun, has a year's duration of 4,332 days. Saturn makes a complete revolution in 10,759 days. That's nearly 30 Earth years, being practically the farthest planet from the Sun. Uranus completes a circle in 30,685 days. Neptune has the largest orbit and has to travel the greatest distance during its year, which lasts 60,190 days, almost 165 years. Also, each planet rotates around its axis at a certain speed, which makes the length of the day on them different. Is Pluto part of the solar system or not? Since the 19th century, scientists have hypothesized that there is a ninth planet in the solar system that is farthest from the Sun. In 1930, 23-year-old Clyde Tombaugh, an employee of the Mount Wilson Observatory, succeeded in finding Pluto. He did this by regularly photographing the starry sky and looking for moving elements. The object was found in the Kuiper Belt region. In the same year, Pluto was officially declared the ninth planet. Due to a lack of data, it was compared in size to Earth, but further research revealed that it had a radius of only 376 kilometers and a mass 6 times smaller than that of the Moon. The planet's surface consists mostly of rocks and ice. Like most Kuiper Belt objects, Pluto has 5 satellites. The orbit around the Sun has an oval shape, and at maximum approach the planet is closer to the light than Neptune, and at its greatest distance the distance is 7.4 billion kilometers. During further studies of the Kuiper Belt, scientists found several other small planets, the size of which is not much different from Pluto. In 2006, it was decided to dwarf them. Pluto has since officially ceased to be the ninth planet in the solar system. However, some scientists still insist that it should be moved back from dwarf to major. Other objects: in addition to the Sun and planets, there are other objects in the system. These include dwarf planets that are inferior in size to the major planets. Kuiper Belt, a disc-shaped region containing many icy bodies. Located beyond the orbit of Neptune. Oort cloud, a cluster of icy conglomerates. Comets, formations of gas, dust, and ice moving through space. Asteroids, rock formations traveling between Mars and Jupiter. Meteorites, small solid objects that fall to the Earth, turn into meteors when they hit the atmosphere, and burn up before reaching the planet's surface. Sometimes asteroids and comets from neighboring galaxies can fly into the solar system, but this phenomenon is quite rare. The Oort cloud is outside the solar system. The Oort cloud is located around the solar system and the Kuiper Belt. Its inner limits begin at 200 to 500 U. Its distance from the Sun and outward is 100 to 200 U. To facilitate study, researchers divide the region into outer and inner parts. The cloud is made up of trillions of particles consisting of ethane, water, methane, ammonia, hydrogen, and other substances. Among them there are rocky asteroids, which make up 2% of the total number of objects. Almost all bodies are less than a kilometer in diameter, with dwarf planets being a rare exception. Interplanetary space. Many people think that there is nothing between the planets. However, this assumption is incorrect. The Sun constantly emits charged particles that travel through space at 1.5 million kilometers per hour and form the heliosphere. This current is called the solar wind. If an object doesn't have its own magnetic field holding back the atmosphere, the charged particles will literally tear it apart. A similar fate befell Mars and Venus. Colonization. In the 20th century, space was actively explored not only by observing it in a telescope, but also with the help of various satellites, shuttles, rockets, etc. For life, unfortunately, a cataclysm may occur on Earth at any moment, so mankind needs to find a new home. Therefore, the possible colonization of space is not an empty sound for modern observatories. In the last century, probes have been sent to various planets and have continued to relay information about their journey. This helps to better understand the structure and properties of objects of the solar system. As for direct colonization, sending Mars rovers to circle the surface of the Earth's satellite and the fourth planet in search of life and other unusual discoveries is already the order of the 21st century. However, now humanity is only on the threshold of space travel, so it is not necessary to talk about a possible flight to another planet. Moreover, most of the large bodies of the solar system are unsuitable for life. Why the solar system is stable? All the planets revolve around the Sun in their orbits, without touching each other in any way. They are also constantly affected by the attraction of the stars, which is based on the law of universal gravitation. And since there is no friction in space, the planets move at a constant speed, and for billions of years the solar system has enjoyed enviable stability. Earth's place in the solar system can be called the most favorable, since life originated on this planet. The third planet revolves around the star on ellipsoids. The maximum distance between the Earth and the Sun is 152 million kilometers and is called aphelion, and the minimum distance is 147 million kilometers and is called perigee. An interesting fact is that while traveling, the Earth reaches aphelion in June and perigee in January. At the intersection of these points, the planet begins to experience a steady cooling or warming. Due to its favorable location, the Earth is constantly warmed by the Sun's rays. Depending on the season and location, the surface temperature varies from -89 to 57 degrees Celsius. This is sufficient for the origin and development of life. The solar system's place in the galaxy. In the Middle Ages, it was believed that the Earth was the center of the universe. Since it was impossible to estimate the size of the room at the time, this assumption seemed the most logical. It was later discovered that the planet is just a part of the solar system centered in a giant star. And even later, it became known that this is only a part of a large galaxy, the Milky Way, which, in turn, is one of many in the universe. Scientists have created a global map of the Milky Way. It encompasses all known boundaries and has a total width of about 100 light-years. For convenience, the galaxy is represented as a flat disk. The solar system is located almost sideways, 28,000 light-years away from the center. Exploration of the solar system. Since the middle of the 20th century, people have been actively trying to explore the planets of the solar system. In 1957, the Soviet Union launched Sputnik 1 into Earth orbit. He spent several months in space gathering information about the planet. Over the next 2 decades, up until the 1980s, people sent travelers to most of the planets in the system, taking many close-up photographs. This helped to create detailed descriptions of objects and study composition. Now every day scientists receive a lot of information about the planets of the solar system, which is transmitted by dozens of satellites. Why do the orbits of the planets lie in the same plane? In the solar system, the star and planets are on the same level. Only a few orbits are slightly tilted. Scientists believe this is because the objects formed at the same time and from the same material. During the collapse of the galaxy when the solar system was born, the gas cloud gradually narrowed and turned into a rotating disk. Therefore, when the planets of the future began to turn into condensation, they were already at the same level. The motion of the planets around the Sun. The ancient Greek astronomer Ptolemy was the first to suggest that the planets and the Sun do not remain stationary, but rotate in their orbits. However, due to lack of technology and knowledge, Scientists believed that all objects revolved around the Earth. Nicolaus Copernicus hypothesized that the planets revolved around the Sun. He built his own model of the solar system and, on its basis, wrote the rotation of the celestial balls. The work was published in 1543 in Nuremberg. Sometime later, Kepler showed that the orbits of the planets are not circular but ellipsoidal. In 1687, Newton discovered the universal law of gravitation, which explained the interaction between the planets and the Sun. Interesting fact, Newton's law helped to prove that the tides on Earth are caused by the activity of the Moon. Now people have enough knowledge and technology to predict the exact trajectory of any planet. Based on this information, rockets and satellites are launched to meet the target at a certain point in space and after a certain time.